This video is sponsored by codingskill.net. Please visit our sponsor. Let's work through binary search problem. In the problem decomposition step, we will divide this problem by half. The original problem has m elements in the array. The left half of the list is a subproblem where the element that we are searching lies on the left half because that element is less than the element in the middle. If x, the element we are looking for, is greater than the element in the middle, then we are going to consider the right half of the list. Here are the steps for the binary search. We first compute the middle index. If the element in the middle is equal to the element we are searching for, base case returns that middle index. In step 3, we search for x in sublists to the right or left of the middle element. Step 4, we return -1 when the list is empty. What is the time complexity? If you have seen the video on guessing game, we derived this equation and proved that it's log n for something that gets divided by half. The equation for the time complexity can be expressed by this equation. Worst case is log n. We derived this equation in guessing game video. Let's consider an example. We will search for 8 in this list. This is the original list. These are the indices for the elements in this original list. Since 8 is greater than the element in the middle, we will consider the right section half of the original list. This is the sublist for recursive call. The indices for these elements are now 0, 1, and 2. You can see the element that we are searching has index 5 in the original list, whereas it is 1 in the new sublist. So we need an extra parameter that contains the position in the original list. This parameter is called lower. So what is the base case? When the list is empty, we will return -1 to indicate we did not find the element in the list. Otherwise, we check the base case for the condition if the element we are searching for is in the middle of the list. What is a recursive case? If x is not at index middle, recursive call on the sublist is based on the condition the element is less than the element in the middle of the list. The binary search method consists of 4 parameters. A is the list, the array. X is the element we are searching for. The lower is the parameter that keeps track of the index because the index changes when the sublist is, size is reduced from the original list. This can be calculated instead of passing it as a parameter. So the first base case checks if the lower is greater than upper. If so, it returns -1. So in this case, indices cross each other. Else, we find the middle index of the list and we check if the element in the middle of the list are the same. If so, we return the middle index. Once these two base cases are handled, now we will make a recursive call. If the element is smaller than the element in the middle, We will look for the element in the left half of the list. So the lower stays the same and the upper becomes the middle minus 1 because the middle is handled by the base case, and we only need to check from lower all the way to one element less than the middle index. Otherwise, we have the case where the element could be greater than the middle element, which means it lies in the right hand half of the original sublist. So in this case, the lower becomes middle plus 1. We exclude the middle because it's handled by the base case. And the upper remains the same as the passed in parameter. This is the upper limit of the list and points to the end of the list. So we can use a binary search wrapper that just takes 2 parameters. So the interface is simplified, and we initialize the lower and upper based on the beginning index of the array, which is 0, and the end of the array, which is array length minus 1. Sign up for your free coding interview coaching call. Sign up for your free coaching call by going to codinginterview.coach.